Okay, I wanted to go over the concepts covered on the Canvas quiz last week, or whatever that was, April 3rd. So I'm going to work through some problems similar but not the same, just so you can kind of see how these work. So first, looking at transformations. If we have a parent function and we have a transformation, then we need to think about the pattern. So y equals, this is a log function, so y equals a times log base b of x minus h plus k. So thinking about that, when we do our transformation on x becomes x plus h, remembering that h is the opposite. And our transformation on y becomes a times y plus k. Now for this function, my a is 1/2, my h is -2, and my k is 4. Oh, there we go. My k is 4. So when I do my transformation, I'm going to take my x minus 2, or plus -2, and I'm going to take my y, multiply it by 1/2, and then add my k value of 4. So they're asking us to do this transformation on this point. So 81 is my original x value, and now I'm going to transform that by saying 81 minus 2, which is 79, is my new x value. And 4 was my original y value, so now I'm going to do the transformation 1/2 times 4 plus 4. 1/2 times 4 is 2, plus 4 is 6. So my new point is at 79.6. Okay. All right. The next problem, and remember, as always, the notes for this will be posted as well. Okay, so for my next problem, it asks you to identify the domain and range. So remember, for log functions, you have a vertical asymptote at x equals h, and so your domain is always going to be x is greater than h, and your range will be, because it's going to be kind of that shape, your range is going to be y is the set of all real numbers. Okay? So for this particular function right here, we're looking for the h, which is -7. So my domain is x is greater than -7, and my range, y, is a set of all real numbers. Now, for exponential functions, it's reversed. Remember, for exponential functions, we have an asymptote of y equals k, and it's this shape, or, well, or the inverse. Generally, it's the shape. So our domain is x is the set of all real numbers, and our range is y is greater than k. So for this particular function, my domain is going to be all real numbers, k is 9, so my range will be y is greater than 9. There we go, sorry. All right. For the third problem, let's see if I can get this on the screen a little better. There we go. All right, for the third problem, you were asked to find the inverse of a log function. So remember, if we have, I'm doing that. If we have y equals totally blanking out for a second, sorry. Okay, if we have a equals b to the x, then okay, start over. What am I doing? Inverse. Okay, I have to flip x and y. X equals log base 5 of y, and then I need to solve for y. This is what I was talking about. I was getting ahead of myself. All right, so if we have a equals b to the x, we have to remember that that becomes log base b of a equals x. So I'm going to rewrite this from log form to exponential form. So this is 5 to the x power equals y. So the inverse of the log is the exponent. Let's go the other way. I'm going to switch x and y. So x equals 5 to the y power. And then I'm going to rewrite this as log form to get y by itself. So log, the base stays the base, of x equals the exponent. Okay, so you can see going from log form to exponential form and exponential to log form that the opposite of a log function, or sorry, the inverse of a log function is the exponential function. Whew. All right, and then number 4, the last one. Here I'm going to rewrite my bases, find a common base. So these are both powers of 3. So this is 3 to the 4th power to the x plus 7 equals 3 to the 3rd power to the x minus 5. And then when we raise a power to a power, we multiply the exponents. So this is 3 to the 4 times x plus 7 equals 3 to the 3 times x minus 5. Okay, the bases are the same, which means the exponents have to be equal. So 4 times x plus 7 has to equal 3 times x minus 5. Distribute, and I get 4x plus 28 equals 3x minus 15. Subtract 3x. X plus 28 equals negative 15. Subtract 28. X equals negative 43. Okay. All right, that's it.